Docker is nothing but lightweight containers that will have packages, dependencies like configuration file libraries, and it will run on the same OS with the isolated user space.
Okay, good. Basically, one of the reason why Docker came into picture is to save resources, to save time. What I mean to say here is, um, say, why do you want to have a laptop with you? In order to probably browse the website, browse internet, do some operations, right? Basically, it is running some processes, it is serving something for you. Similarly, any application that you run that requires a physical machine or a virtual machine, any application is nothing but a service or a process, right? If there is no process running, you will not be able to access anything from that particular machine. Is that clear to you? So then only we can move on. What is meant by an application? What is meant by a service? What is meant by a process? You have a clarity on that? Akshay, Darshan.
Yes, sir, a basic process.
Okay. So I'll give a introduction on Dockers. Even in a virtual machine, what we will be running is a process, a service that will be accessed by external customer or external application. Usually, a simple example would be a web server. Sometimes it becomes too difficult or too costly to run a EC2 machine or run a physical machine to serve a single process, to run a single process and make sure the customer is served for his request. Instead of that, we can run an isolated process in a Docker container, and we can run multiple processes of different applications in the same machine, so that we can effectively use the hardware or the virtual machine. Some of the important and most prominent features of Docker is it is portable easily to anywhere. That means it can be copied, or the entire Docker container can be moved to a different system. It is lightweight in nature because it doesn't have any kernel. It doesn't have any uh, associated hardwares. So it uses a virtual machine's hardware and kernel, and only required libraries and binaries are packaged and shipped along with the Docker container.
Sir,
Yes,
will not work with cross OS, no, sir?
it will not work for cross OS. If you build a container on Linux, it will not work on Windows. If you build a
Like Linux flavors, it will work, no?
yeah, Linux flavors, it will work. See, overall, every operating system, the whole operating system is uh, bifurcated by Linux or non-Linux. Everything else is Linux apart from Windows.
Yes, got it.
So when you run a PS command, any idea when you when you get a chance to work on a remote Linux machine, say EC2 machine, have you
That will show the processes.
processes
Whichever.
running, right? Say, for example, I'll give you one quick example for you. Maybe one of you can share your screen and connect your EC2 machine from console. We'll just quickly see this example, why I'm talking about process, how process is important for Docker containers. Who has a physical, sorry, EC2 machine ready? Darshan, you have the EC2 machine started?
Yes, sir.
Can you share your screen?
My screen visible, sir.
Yeah, okay. Do a ps dash ef. Yeah, okay. You can do a pipe grub ssh. Pipe grub ssh. No, no, no. Use up arrow. Up arrow. Uh, pipe. Pipe symbol is just above the return command. Grub space dash I. No, dash I. So that if it is having smaller or capital letter, it will match. Space SSH. Basically, you are trying to see whether SSH service is running or not. Okay, this is one of the common example that I give it to students. So, okay, enter. Enter now. You will see. Uh, you can highlight the first line, right? SSHD. What is SSHD? Any idea? Yes, secure shell daemon. Daemon is nothing but a process which is running in the background. Okay. Can you go to your Git bash? So, any questions so far? What is running? How we can see whether the process is running or not? Akshay, can you tell me what are we currently doing?
Uh, we are connecting to EC2 instance where
And
this Docker.
the process, checking the running process and trying to search for SSH process.
There are also one more thing. If
Hmm.
this Docker is running, can we interrupt it in the between? Can we stop it?
Yes, yes, we can do pretty much whatever you want.
Apart from us, is there any other factors, external factors that will affect its running?
Uh,
Anything that will interrupt it without our knowledge, or is there something like that? For example, one Docker is running and some other process it disturbs it or interrupts it. Is this
See, normally Docker containers are not reliable,
hmm,
but
okay?
you
They're
you cannot
isolated. Yeah.
you cannot. But at the same time, it is not like, I mean, somebody can simply access it. It is all, I mean, unless you know what port it is running, what is the service you are running, you cannot really access the particular Docker container. It will be running, but there is no guarantee how long it will be running. That is why we need orchestration.
That falls under Kubernetes, right?
Yeah, correct.
Okay.
So
Okay.
with respect to process, that's a fundamental understanding before we go to Docker containers. That's why I'm asking whether you have any questions on process which I'm trying to explain. What is SSH service that I'm trying to explain? Do you have any questions on this one?
Sir, one application have multiple processes.
Yes. See, on a virtual machine, you will have at least minimum 10 to 15 processes running. Otherwise, your virtual machine will not be able to access from outside world. You will not have any purpose of running a virtual machine if there is no process running. That means the server is shut down. Now, can you go to okay, you are in the scripts folder, right? Do a pwd. Okay, /direct connect.sh, direct login.sh. And
It's showing some errors.
pwd. Okay, whatever modifications you have done it on the different folder. Okay, do one thing. Do a cd space dot dot slash uh, dot dot slash scripts. Enter. Maybe you ran it from here yesterday. Just repeat. Repeat your dot slash direct login.sh. Later you can change the again. You were able to log in yesterday or not?
Yes, yes, sir. Yes, sir.
Your something is messed up again. Okay, do one thing. Vim space uh, direct tab. No dot. Direct. Uh, Enter. Go to the first line. I zoomed in. Okay. Comment out the second line. ec2 underscore key.pem comment. Put a comment over there. Save the file. You have a ec2-vpc.pem right here in this folder. Do ls. You don't have a ec2-vpc.pem file.
Is there in Code Cloud Plus?
Do a cd space dash. Do a ls. ec2-vpc.pem is there. ec2 underscore vpc. What is this pw? Can you just do a pwd? Cloud VPC is it. Controller AWS S3 CP. Enter. ls. No, just remove the hash. Up arrow, remove the hash. Control A. Okay. Enter. Do ls. Go to get ip.sh. Vim space get underscore ip.sh. Go to insert mode. Enter. First line prof equals whatever we have done yesterday. Equals. No, don't give a space. It's not like Python. Shell is very sensitive. Code dash cloud. Code dash cloud. Code dash cloud. KLYOD. So escape, save this file. Come out. Open direct login.sh. Vim space direct login.sh. Put a hash for the key file, the second line. Yeah, save the file. Do a /direct login sh. This is very simple. Just do a /direct /d tab. Uh,
So
okay,
now
it's connected, right?
yeah.
Do a control D shortcut that can be used to log out. Again, do a up arrow and enter. What does it say? It is able to log into EC2 machine because what is running in the EC2 machine? What is running in the EC2 machine? It is running SSH service. Okay,
SL
do a control D once again. Okay, can you go to your AWS console? The console login. Yeah, go there. Do a systemctl sudo systemctl sudo stop sshd. You're basically trying to stop the service which is already running on this lab machine. Okay, do it. Enter.
SSHD, no, sir.
Yeah, D. D is the daemon, the service name which is actually running. Yeah, enter. So use up arrow to run the same command grep ssh. Yeah, enter. Uh, is it still running?
This one is not running, sir. First one.
It is not running. Okay, that is not running. Okay, it is just showing the grep command. Can you come back to git bash? Yeah, use up arrow and then run the same command. What is it saying? It is
Connect to host failed.
Yeah, it is able to get the IP address from AWS CLI because the machine is running, but SSH service is not running. It is saying connection refused. Port number 22, connection refused. What do you understand from this particular message and what have you learned today? Do let me know.
Sir, SSH is the process which is running for the EC2 for
Yes,
connecting remote desktop machine. So
yes,
if we stop that process, means it will not connect to the EC2 instance.
correct. Okay. Say if I want to run a web server on my EC2 machine, what should I do?
We will stop HTTPS.
Will run, no, if I want to run, I
If you
will start HTTP service.
yes,
What is the default port for HTTP service?
80, sir.
Port 80. So when I run that particular service, it becomes a web server. Your EC2 machine becomes a web server, right? When you run SSH service, it becomes a SSH server. Say there is some other service running, say database service. That becomes a database server. Like that, a single machine can become a multiple server. At the same time, it is very difficult to run two SSH server on the same machine. It is very difficult to run two web server on the same machine on the same port. It will conflict each other and it will not be able to run. That is why we need Docker in place that takes out only the libraries, binaries required to run a particular process and it runs an isolated process. So you don't need to worry about running multiple instances of the same process. You don't need to worry about running multiple versions of the same service.
It will
That
not get conflict, no, sir.
it will not get conflict as long as you are running in different port numbers. Okay, now you can go back to your AWS console, use app arrow, um, one more. Yeah, instead of stop, just change it to start. Okay,
No, sir.
you're able to understand, right? Okay, now do one more thing. From here also you can do sudo yum install Apache. Sudo yum install Apache. Yeah, enter. It should probably work. So change it to HTTPD instead of Apache. HTTPD. HTTPD. Say why? Because this is your web server which you are running. Uh, can you do a can you find the IP address going to the easy to machine ones?
Yes,
Yes.
Yeah, that also you can do. Yeah, correct. Does it show the public IP? It does not show the public IP address. Do one thing, press Control D. Okay, connection to this particular host is closed, right? Copy that IP address. Double click. Yeah, put it in the browser. Go to the browser, do a Control T, put it there, enter. If it is not displaying any page, what does it mean? What does it
so
mean?
it is blocking firewall.
Not blocking. It is not running on the machine. Okay, do one thing. Sudo systemctl start HTTPD. Systemctl start HTTPD. You installed a service called process called or HTTPD and you are starting the HTTPD service. Yeah, enter. Use up arrow and then instead of start, put status. That is to check the status of the service. What is
It
it?
was,
It is service running, right?
yes.
Yeah. Now go back and hit the same in the browser. What did you see now?
It works now.
Yeah, basically it is the application is being served by that particular service. Uh, how come it is working? How come you are able to access port number 80?
Sir, we
Because
started here.
no,
HTTP.
you have allowed in the security group to be accessed from outside world. You have given port number 80 in the security group rules. So
Yes,
you,
sir.
it is a combination of two or three different things that you are doing it. See, you initially created a security group, which is allowing some port number access from a particular IP address, and you started your HTTPD service now, and you are able to access it. Um, Now it is not possible to run multiple versions of the same HTTPD service. You will not be able to run multiple versions of database same service on the same port number. So these things can be achieved by running Docker containers on your EC2 machine. Okay. Any questions on this particular topic that I explained so far? Because it is very, very fundamental, very, very important for you to understand Docker containers.
Sir, Docker engine and GitLab engine both are like same.
Not GitLab engine. Why you are saying GitLab engine? Docker engine is okay. What is GitLab engine?
GitLab runners.
Ah, okay. GitLab runner.
Yeah.
See, GitLab runner is totally different from um, services running on your local machine. What is GitLab runner? GitLab itself is a service provided by GitLab as a company. So if you want to run something on GitLab server, you have to have a GitLab runner which is hosted by a GitLab server or a GitLab company. So that will take care of running your services, running your pipelines on a particular dedicated Docker container. That is nothing but a GitLab runner. Say, for example, you want to log into EC2 machine, right? How
Yes,
do
sir.
you log in? There are two ways you can log in, right? One is using AWS console,
Yes, sir.
right? Using AWS console, you can go to the connect option. You can click on SSH connection. That serial console, you are able to log into the EC2 machine. Apart from this, what else you do? You open your
Can
Git,
use.
you open your Git bash, right? You open your Git
Yes.
bash. From there, you use SSH command to log into the remote machine.
Yes.
You have a shell script which is fetching the IP address. You are able to log into the EC2 machine directly, right?
Yes, sir.
You are using a bash or a git bash interface to log into the EC2 machine. So you require at least one medium to connect to the remote server. Similarly, from GitLab, if you want to connect to and run a particular process, a particular job, you need a machine. You need an interface. That is called GitLab Runner. Tell me if you still have a question.
Yes, sir. That one clear. Docker engine is like to manage the containers, no, sir?
Okay, coming back to the point. Docker engine is a process which is running to serve Docker containers. Say, for example, um, you have an operating system, right?
Yes, sir.
For that, you require some processes, some kernel, some other processes should be running on the system. Similarly, for running a Docker container, you need a Docker engine. That is the basic operating system for running Docker containers. So you can say that Docker daemon is a Docker operating system. So to put it in a simple word, it is a Docker operating system is nothing but a Docker engine or Docker daemon. Okay. Now, can you do a ps-ef pipe grub docker from your, yeah, enter direct login.sh, enter, just enter. So you'll be able to log into the EC2 machine. Okay, now do a ps-ef pipe grub -i docker. You are basically searching whether Docker engine is running or not. Grub pipe grub -i docker. So if you have already understood, you are trying to see whether a Docker operating system is running on this machine or not. Okay, enter. Because we already have installed it uh, from the user data that I'll show you again. So can you see that Docker D, which is using a 3855 process ID. Can you just highlight the 3855 number? Just double click 3855. Yeah, that's a process ID for Docker container. If you want to just stop Docker container, you can simply do a sudo kill -9 3855. Your Docker D process will be stopped. Sudo kill -9. This is to kill a process which is running. -9 is to kill forcefully. If you use up arrow
Is this
after,
correct, sir?
yeah, that is correct. Yes, this is the way to kill a particular process, especially if some process is hung, you can kill the process like this. So after this, I mean, you can use up arrow. Just see whether Docker is running. Okay,
No, sir.
Docker is not killed, or is it killed?
Killed, sir. No, here not that process ID.
It is basically running it again because it is configured such a way that, I mean, Docker daemon should be running always. Just do a Docker sudo systemctl stop Docker D. Probably some configuration that is done to run the Docker container always. After systemctl stop. Let's see if this works. Otherwise, I mean, there is some other system configuration which is stopping us from killing the service, killing the process. Okay, fail to stop. Unit Docker D service not loaded. Uh, instead of stop, can you do a reload? Systemctl reload. Enter. Okay, maybe it is. Do a Docker PS, Docker space PS, Docker PS. Okay, Docker is actually running. It is not killed. Okay, say forget about, I mean, killing the Docker daemon or stopping the Docker daemon, but you should have a Docker daemon running for you to run Docker commands. So Docker daemon is your server, Docker is your client. Similar to your browser, which you are running to access web application. That is a web client, whereas the server which is running Apache server or the HTTP server which is running on the remote machine is called web server. Similarly, you have a Docker service running on this machine, which is nothing but a Docker server, that is like Docker daemon, whereas Docker command that you are using, which is a Docker client.
Yes.
Okay. I hope, I mean, I made it clear about Docker containers. I'll move on.
Sir,
Uh,
one doubt.
Yes, yes.
Like if Docker will use a OS means will not use the host OS. No, sir. Docker will have their own OS.
Yes, yes. Docker containers will make use of the binaries and libraries from the system. That's all. It will run on top of the virtual machine operating system. Clear?
Yes.
I start sharing my screen once again. So we saw this process is running on the Linux machine. So I'm just going to explain few things. It is lightweight, standalone. Um, One of the reason why we use Docker is to have consistent environment because we are defining almost everything in the Docker file. So whenever you spin up a new Docker container, it will be consistent irrespective of how many times you are running the Docker file, how many times you are running the Docker container. So at the start, it will be consistent, but after that, whatever changes you make to the container, it's up to you. So at at least at the starting point, each Docker container you are running for a particular purpose, it will be consistent across environments. So this is one of the most important uh, terminology or important concept that you need to understand is it provides a consistent environment for development, testing, deployment. That is basically to ensure the application runs smoothly uh, at any time. Docker is a process, like I told you, similar to what I compared, right? It is just an executable package or a process which is running inside a Linux machine or a Windows machine, which contains um, a Docker file, some instructions, and some runtime and libraries, and that will be running on a particular port. Any questions on this one? So,
Sir,
like, yeah,
sir, if the Docker is running, no, sir, that
uh,
time if we made any changes, no, sir, that it will be automatically update or we need to do some code changes or need to run some commands.
so when the Docker container is running, you cannot do any changes for the running containers. If you want to apply the changes in the running containers, you need to stop and you can restart the container.
Oh,
You,
okay, sir.
you cannot apply changes to the running containers. It is isolated, it is portable, it is efficient, it is consistent, and very less boot time, very less resource usage. All of these are some of the fundamentals or some of the key concepts of Docker. What are containers? Containers are the service which is running, um, which is nothing but a um, which is executed by Docker run containers. Docker images are just operating system images for the particular Docker container. Docker file is a base or the root for creating a Docker container. Docker file contains some instructions about which is the base image and what are the different dependencies, what are the different commands that you're running. That will be mentioned in the Docker file. So it should be like this: a Docker file is written first, and then Docker image is created next, and then your Docker container is created. So the workflow should be Docker file, Docker images, and Docker containers. So Docker Hub is a place where you store all the container images. So basically to store images, Docker images, we use Docker Hub. When you run the Docker container, you should do a Docker pull. So this is nothing but pull. This is pull. This is push. The images that will be pushed to Docker Hub, images that will be pulled by Docker pull command, and containers will be deployed and containers will be running. So volumes we need to see, because normally Docker containers are ephemeral in nature. That means it can be killed or stopped anytime. So you will lose your volume. But in order to make sure the volume is persistent, we have to mount the volume to the local file system, so that file system volume remains same. Your Docker container is, even though when your Docker container is restarted. Okay. I'm having a comparison of virtual machine versus Docker container. Everything we already saw. Low, lightweight, fine grained isolation. It uses Docker engine. So this
Sir,
port number, yes.
vulnerability means it is a virus or something. Isolation, strong but no vulnerability in shared hardware and software possible.
Here you're saying,
No, sir, down. In isolation, yeah, virtual machine.
okay. Fine grained isolation, mitigating some shared kernel risk. See, basically, if you're running a say Windows machine, right? Or any Linux machine, that machine will be prone to attacks. Whereas Docker containers, which is yeah, isolated workspace, right? Because of that, it is not known to outside people. You cannot really expose this particular container simply. If you want to keep it isolated, keep it not visible to outside world, you can still do it. That's a way you can control from, you can stop from external vulnerabilities, external attacks. Basically, what it means is, it is not known to people from outside world. It is known to only the local file system or local server. There'll be one person sitting outside your machine. Say this is your EC2 machine, the Docker container is running here, and every request will be coming via this particular person. That is nothing but your host machine. So you will never know exactly what this application is serving, what port it is running. So that's how, I mean, we are mitigating some of the kernel risks, shared kernel risks.
Sir, Docker also a process, no, sir?
Docker is also process, yes, but
Sir,
the
which port number it will use?
Docker, I mean Docker daemon you're saying.
Yes.
I don't remember. Let's see. Yeah, 2375, 2376. You can do one thing. You can do a netstat -nlp in your. So it'll probably show you. No, in my MacBook it is not working. This is not the right command for MacBook. So you can search this. You can do this on your machine and you can find out the port number. Can you just run it and quickly tell me what is the port number it is showing? On the EC2 machine.
Yes, sir.
It requires port number. No. Is it showing any output or no?
Showing, sir.
What is output it is showing? Can you
It is showing.
quickly share your screen?
Yeah. This is the.
Yeah, same for me.
Okay. Basically, it is running. You can use up arrow and say SSH. Then you will understand exactly what port SSH is running. Similarly, Docker probably sudo. Can you use sudo in the front? Yeah. So you can clearly see that it is running on port number 22, right? Like that
Yes.
only, Docker container will also be running. Docker D. Can you use Docker D? Docker D. I'm not really sure what the process will be. Yeah, I think it is showing you right now, Docker D. But it does not show the exact port number in which it is running, right?
Yes, sir.
Yeah. It is probably running on a different port. Uh, so that is a command to check what is the port number which is occupied by the particular service. You can
Like
use
it will change the process. Like it will change the port number, sir,
see
for
you
some
can
other content.
you can run any service on a different port number. The default port number is different always. Default port number is the default port for a particular service. But it is not necessary that you need to run it on the same port.
Okay.
Okay, just use up arrow and then say HTTP instead of Docker, HTTP. It will show you port number 80.
Yes, sir.
Yeah. Okay. Now I'll just share my screen. We'll quickly finish it up another 5-10 minutes. Okay, moving on to the next. So we already saw about what is service, what is the port number for each service. Server means whichever machine which is running the particular service is server, whichever way you're connecting to the server, that is called a client. For you, what is a client? Two different clients you have used today to connect. One is a
Yes.
Git bash as a client for connecting to SSH, and another one is a web browser that you used as a client to connect to a web server, right? Server
Yes,
is
sir.
nothing but your EC2 machine which is running the service. So if you have this understanding, right, you will have a peaceful DevOps learning, because this is a very important concept. What is server? What is client? What is service? What is server? How do we access it? What is the IP address? What is the port number? How do we access a particular port number? So this is very important topic with respect to DevOps. Hope it is clear. If not, please ask me questions.
Sir, it use TCP or UDP protocol.
Normally, all the protocols, all the services will be using TCP as a protocol. Rarely, very few services will be using UDP as a protocol. Say for example, SNMP, SMTP, similar to some of the services that doesn't require any response directly from the customer. say for example you're playing YouTube video, right? It doesn't require any response from it just need to send some videos to the external person. That's all. It doesn't require any interaction from the customer. So like that, the protocol will be UDP. Whereas for most of the interactions, it will be TCP. UDP is it is like connection connectionless, whereas TCP is a connection oriented.
Yes, sir. And response also fast for UDP.
Yeah, UDP the response is fast because I mean you don't require any response from the other end. It is not connection oriented, right?
Yes.
Yeah. You can probably go back and read about protocols. That is also important for you, for DevOps engineer. Moving on to the next one. I already explained. Docker image is nothing but a template or a operating system image. You can simply think that it is an operating system image, which is built based on the Docker files. Docker container is the actual Docker process which is running, not the Docker process. Docker container is nothing but a service running on top of a Docker daemon. Dockerfile I already explained. Docker hub is nothing but a server which is hosting Docker images. Docker
Docker
compose,
registry also we can call, no, sir? The
you
Docker hub.
Docker registry or Docker hub, anything is fine. Docker compose is all about collection of few Docker files and make it work like a single application. Say for example, you have a web server, database server, cache server, front-end server like that. You can put everything into a single Docker compose file and you can run a 3-tier, 4-tier applications. Basically, Docker compose is just above the Docker file. So we'll see it in the upcoming classes. Some of the commands that you need to learn from is all about in the Docker file. From is about which image you are using to run your Docker container. Run is a command uh, that gets executed when it is passed as an argument. Basically, whatever commands that you are running inside a Docker container, that you will use run as a keyword. From keyword is for pulling the Docker image. Copy is as usual, which file you are copying to which location. Entry point is a uh, you might have seen in Terraform Docker container, right? That we are pulling. In that we have mentioned entry point is nothing but uh, saying which path should be used for env so that that particular application will be executed without any problem. Work directory is nothing but you are doing a cd, right? Cd like that work directory. You are changing the directory to a particular workspace and then running the command. cmd is the actual command that you are running, which is nothing but a particular service you are starting, similar to systemctl start a particular service. See, you can see the command apt get update in the run uh, keyword. Env is something like environment variable that you set in system or in your Terraform, right? That is similar to this one. From Ubuntu latest means Ubuntu is the operating system. From there, you are pulling the latest tag. Work directory, like I told you, it is all about in which directory you are working, in which directory you are going to run a particular uh, command. Copy is all about source, destination where you are copying from the local machine, from your EC2 machine to Docker container. Expose port 80 means you are exposing port 80 for the Docker container. It is all about on what port the Docker container will be running. You can change this port in order to make your Docker container running on different ports, the same service. We'll see examples tomorrow, but we'll see only the theory part for about another 5-10 minutes. Then we should be able to cover so a little bit deeper tomorrow. This diagram you might have seen how the normal deployment on a physical machine and how a deployment happens on a virtual machine. You have virtual machines 1 and 2 here, but here you have a virtual machine which is running. On top of that, you are running multiple Docker containers. You can run hundreds of containers if you are running a single virtual machine and running Docker containers on top of it. So you can say that hundreds of processes can be served by a single virtual machine. If you are running multiple virtual machines, each virtual machine you can host Docker containers, but if you're not hosting Docker containers, it is not very effective. It is not an efficient way to do it.
Sir, there
Yes.
in that image, no, sir, hypervisor is there, that is VMware. But here on the top of operating system, we are running a container runtime. So here VM is not there.
Yeah, so it is default assumed that hypervisor is here. It could be a physical machine or it could be a virtual machine. See, you should assume you are running an operating system right here, right?
Yes, yes.
It is exactly this one. We are not talking about virtual machine. We are directly going to the operating system. Say from hardware to operating system.
That's why it is light, no, sir.
No, 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 no. Try to understand. See, we are running Docker containers on top of a virtual machine. See, this one is a VM. This one is a VM. This VM is all about the whole stuff. They are not trying to showcase everything. So what see, hardware, operating system, hypervisor, virtual machine, right? All those 4 components are included in this operating system. On top of that, you are running container runtime, which is nothing but Docker daemon. Only when you have a Docker runtime, you can run application, Docker containers.
Here host OS is not there, sir.
Where
In the down, their hardware is there, no.
host OS operating system. This is a host OS. They are trying to minimize the number of pieces here. Here on the second diagram, you have hardware, operating system, hypervisor, virtual machine, right? All of them are covered in just 2, hardware and operating system. Operating system is running hypervisor, and in that you are running virtual machine. On that you are running your Docker containers. See, here they meant to say that it is a physical machine. It is a physical server. Okay, but you should understand we mostly run it on a virtual machine, not on a physical machine.
Okay.
So if you see, the same thing is depicted here. You can see that your infrastructure, I mean your hardware, everything, and you have a host operating system. Here also they don't mention it is a VM or EC2 machine or a physical machine. It could be a VM, it could be a physical machine, it could be an EC2 machine, it could be anything on the cloud. On top of that, you will be running a Docker engine. Docker engine is nothing but Docker daemon, and you'll be running multiple containers on top of it. Okay, is
Sir.
it clear?
Yes.
So it is the same thing. Docker commands that you're running is Docker client. Docker host is nothing but your Docker server. It could be a remote machine or it could be a local machine. Docker Hub is nothing but a registry where you store and pull Docker container images. So the same thing is defined here. Building an image, running a container, pushing to registry, and pulling it and deploying it in the container. Pulling it and deploying it in the EC2 machine. Running a container. Running a container is nothing but deploy. Simply run a container manually. That also means you are deploying a container. Basic workflow: create a Docker file, build an image, run a container, push it to registry, pull it from registry and deploy it. So how do you build an image? Using build command. How do you run a Docker container? Using a run command with the port number and the application name. How do you pull from a Docker container? You have to log into the Docker Hub, and then do a Docker pull with a tag. And this one is to show you what are the different images that are available in your local system. Push to Docker registry, you need two commands, Docker tag and then Docker push. So it is similar to your Git command. You want to pull anything from the remote repository, you have to do a Git pull, right? If you want
Yes.
to push anything to the remote repository, you have to do a Git push. Similar to that, you will do a Docker pull, Docker push. You should connect with your Git so that it becomes easy for you to understand.
That name should be like Docker registry, whatever they that need to do. No? My
Whatever,
Ubuntu.
yeah, whatever name that you have created, that you have to use it here. Otherwise, here, whatever their name, it is available in the Docker Hub, that name you should use. So we'll slowly see and understand, but if you understand the concept, it will become easy for you to work with Docker containers. So workflow is very important, and then different commands are very important. For building a Docker image, Docker build. For running a Docker container, Docker run. For pushing an image, Docker push. For tagging an image, Docker tag. For pulling an image, Docker pull. So like that, if you just look at the way you do it on Git, you will probably have better understanding.
Yes.
So at the client side, what do? You do a Docker build, Docker pull, Docker run. When you do a Docker push, it will automatically go to Docker registry. When you pull from the registry, it will automatically come to your local. Whenever you do a Docker run, you require a Docker daemon. So for everything you require a Docker daemon, but when you run it, it will become a Docker container. It will be running on your either on your local machine or remote machine, local or remote. It depends on your configuration. Docker will be running on your local machine. From your system also you can run, from your Windows machine also you can run. You can deploy it on a remote EC2 machine. So your EC2 machine could be a Docker host. The same thing is explained.
Also,
Yes.
I'm running out of time, sir. Tomorrow we can discuss. Like
Sure.
Akshay also left.
Oh, is it? Okay. Sure.
Yeah.
Okay. Sure. Okay. Thank you.
Sorry.